Start with questions from homeworks. I think I left you guys with 3.9 homeworks. What was that?
Yeah, 24.
Okay. All right, 24. It says a trough 10 feet long, or trough is 10 feet long, and its ends have the shape of isosceles triangles that are 3 feet across at the top and a height of 1 foot. If the trough is being filled with water at a rate of 12 cubic feet per minute, how fast is the water level rising when the water is 6 inches deep? Okay, so if I think about this, so it's going to look kind of like this, right? So I'll call this piece B. I'll call that, well, I'll call it BT, HT, and then I'll call this L. So I know the base of the trough is 3. The height for the trough is 1. The length for the trough, and really that length is a constant, right? Whether you're talking about the trough or the water, is 10. And we have dV dt is equal to 12. And we're asked for dHW dt when HW is equal to 6. So far, so good. So if I kind of fill this in, so this is like my HW, my BW, and then like the LW is the same as the trough, right? That part's not changing. In fact, that's a constant. So far, so good? Okay. So, do you remember the volume for a prism? So the volume for a prism is going to be the area of the base times, well, let's say the length. And what shape is the base? Triangle. So the area there is 1/2 base times height. Feels so far so good. Now, this guy's a constant, so we don't have to worry about this. But I know I want to know about HW, but I don't want anything to do with BW, right? I need to eliminate that from my formula because that's a variable, and if I differentiate right now, I'm going to have to do a product rule, and I'll get a dB dW, and I don't have any place to, or dB dt, and I don't have anything to do with that. So if I look at the base of that triangle, or the base of that trough, should see a pretty easy similar triangle situation, right? So I'll say that BT over BW equals HT over HW, or I'm sorry, HT, no, HW, sorry. Now, the trough is 3 feet by 1 foot. So if I cross multiply, BW is equal to 3 HWs. So I have that. So far, so good. And I know that the L is 10, so that's just going to be 15 HW squared. And now I think I'm ready to differentiate. So dV dt is equal to 15 times 2HW dHW dt. So far, good there. And then I know HW is 6 inches. Everything else is in feet, so I'm going to have to convert that into feet. So I'll call it 0.5 feet. So I have 12 is equal to 15 times 2 times 0.5 dHW dt. So 12/15 is dHW dt. And I think that should do it. I guess that's foot per minute. Does that feel okay, Lucas?
Where do you get 0.5?
Well, it says that HW is 6 inches, so I had to convert it to feet because all the other units were in feet. Or I could have converted all the other units to inches, but like, ugh. Right? Give me 1 conversion versus 5. But I had a unit mismatch going on. That's a toughie. Right? Any of those that you have to eliminate a variable. But that similar triangles trick is there's a triangle in there and you have to eliminate a variable. It's usually going to be a similar triangles thing where you just write a proportion. Right? That's the most common variable elimination trick, is just using a similar triangle. Other questions or follow-ups on this one, if there's still more to talk about here. I tried to be relatively detailed when I did that. Elena? Yeah, 28. That's a kite, huh? Did you guys notice if you were using the PDF that you downloaded that this page was missing? Super annoying. I put the missing page in the OneNote. All right. So it says a kite 100 feet above the ground moves horizontally at a speed of 8 feet per second. At what rate is the angle between the string and the horizontal decreasing when 200 feet of string have been let out? So I'm going to draw myself a triangle. So there's the kite and the person. Everybody's okay there? Let's see, what are we told us? We told y is, well, a kite is 100 feet above the ground, moves horizontally at a rate or a speed of 8 feet per second. Really, that's saying dx dt when when y is 100 is equal to 8 feet per second. Y is not constant though, right? It's just saying at that instant. At what rate is the angle between the string and the horizontal decreasing? So d theta dt when r equals 200 equals what? Let's read that one more time. I feel like I might have misplaced this thing. A kite 100 feet above the ground moves horizontally. Yeah, I think that I don't think that's supposed to be there. I think that's just going to be, I think that's constant. I don't know that we can do it if it's not. Okay. All right. So, which equation do you think we want to use for this? I would probably want to include y and r, right? Or alternatively, we could do yeah. So we'd have here that have like sine theta equals y, well, let's say 100 over r. What's the problem going to be though? We don't know r, right? So let me just double check here. Oh, I'm doing this terribly. Here. All right. Let's go back. Yeah? Sure. All right. So let's think about it this way instead. We know something about dx dt, right? We know y is constant. We're going to find about d theta dt. What equation is going to relate x, y, and theta together? Tangent or cotangent? Does it matter which one I choose? Probably not, right? So you said tangent first. Tangent theta would be y over x, or really 100 over x. What do you notice? It's kind of a downside there. X in the denominator, not that big of a deal. If we did cotangent theta, that'd be x over y, so x over 100. Which one would you rather take the derivative of? Maybe the second one, right? Where you don't have the to deal with the negative exponent. Does it really make much of a difference? No. Is one much harder than the other? No. Are they both going to work? Yeah. Does it matter? No. I'm going to do the second one because it seems just like the calculus is a little bit easier. So the derivative cotangent is negative cosecant squared d theta dt equals 1 over 100 dx dt. So far, so good. So I'm going to multiply both sides by 1 over negative cosecant squared, which is the same thing as 1 over negative cosecant squared. Go back to trig. Negative sine squared, right? 1 over cosecant is sine. Yes? Yeah? So far, so good? Okay. At the instant we're concerned about, r is 200. So what is sine of theta going to be in this triangle? Opposite over hypotenuse. So it'll be 1/2. Yes? Can you see it? And our dx dt was, what was it? It's 8 or something? 8. And so what is that? Negative 1 out of 50 or something? Oops. What was my unit there? Was per second. Okay. Elena, is that okay? After stumbling around for a minute, picking the equation at the start, but sure, go ahead. So I'm doing sine squared theta, right? So I remember that sine squared theta is like sine of theta squared, right? It's the same thing. So I'm going to go to my triangle and compute sine of theta. So sine is opposite over hypotenuse, 100 over 200, which is 1/2. So that's where the 1/2 came from. Sure. Other questions from homeworks? These are probably the two hardest ones, yeah? Okay. Well, the remaining 60 minutes or so, I have a handout containing more related rates problems for you guys to practice in class. You can work by yourself, with a partner, with a group. You can choose your own groups. Whatever you want to do is fine by me. That's what I'd like you to do for the remaining 60 minutes here of class, is just to work on this single topic and try to get a little bit better at it than you were when you walked in the door.
Thank you.
Sure.
You are.
Don't know to draw that. See?
Straighten it out.